What if everyone on Earth sneezed at the exact same moment? It sounds like the setup for a dad joke, but let's explore the chaotic, scientific, and surprisingly catastrophic consequences. First, imagine the sheer number of sneezes, roughly 8 billion people, each producing a tiny gust of air at speeds that can exceed 100 kilometers per hour. Normally, one sneeze is barely noticeable, a quick, harmless puff. But 8 billion, that's like trying to calculate the impact of a sudden, invisible hurricane blasting from every corner of the planet simultaneously. Let's start with the atmosphere. A sneeze generates a localized wind, capable of moving tiny droplets, and even a bit of dust. Multiply that by billions, and suddenly, we're looking at a global scale gust that, while not hurricane level, could disrupt delicate weather systems. Tiny variations in air pressure could amplify one another, causing unexpected storm patterns, sudden gusts, and a temporary spike in wind speed. Meteorologists would scratch their heads as clouds abruptly swirl in strange directions. Birds would be flung off course, and kites everywhere would go rogue. Now, consider the immediate physical impact on humans themselves. A synchronized sneeze isn't just a gust of air, it's also a pressure spike. Sneezing produces a momentary force in your respiratory system, and while the human body can handle it easily alone, the sudden global synchronization would create a ripple effect through the ground. Each sneeze's impact on the atmosphere transmits as a minuscule vibration. Multiply that by billions, and suddenly, we're not talking about a gentle tremor, but a faint, worldwide seismic pulse. Engineers and seismologists would detect an unprecedented wave, and bridges, skyscrapers, and delicate infrastructure could experience minor, but noticeable shakes. Forget earthquakes, this is an event that could be called the Great Sneeze Wave of 2025. Animals would react in unpredictable ways. Herds of wildboar in Africa might suddenly scatter, fish near the surface might leap in unison from the water, and flocks of birds could collide mid-flight. Urban pets would panic, and the world's domesticated animals would share our confusion and mild terror. Dogs might bark non-stop, cats would disappear into hiding spots, and some clever parrots would probably start imitating sneezes themselves, thinking it's some new social cue. Meanwhile, in the oceans, schools of fish might be startled enough to generate mini tsunami-like surface ripples in coastal regions. Then there's the microscopic chaos. Sneezes propel droplets at high speeds, carrying viruses, bacteria, and pollen. With everyone sneezing at once, the usual localized spread becomes a planetary-scale aerosol event. Allergists would be horrified. People with allergies might experience simultaneous meltdowns worldwide. Virologists would frantically attempt to calculate the effect on seasonal flu, common colds, and the ongoing dynamics of airborne pathogens. Some diseases could theoretically jump in unprecedented ways, though thankfully, nature's defenses and the brevity of the sneeze itself would limit true disaster. Still, a few weeks of synchronized sniffles and tissues would become the defining global experience of the decade. Vehicles, too, would feel the impact. Planes in mid-flight would experience brief, turbulent gusts that could rock the cabin, just enough to startle passengers. Drivers might sneeze simultaneously with others, causing tiny but chaotic ripple effects in traffic. Minor accidents would spike worldwide. On a lighter note, synchronized sneezing in a crowd could create hilarious chain reactions in slow-moving pedestrian zones. Imagine the domino effect in a stadium, mall, or subway, where everyone's reflexive sneeze causes coordinated flailing and staggering, a global ballet of human unpredictability. Meanwhile, scientists would scramble to understand the physics behind it. Could the combined force of billions of sneezes generate measurable movement in the planet itself? Surprisingly, calculations suggest the actual displacement of Earth would be negligible, but the synchronized energy could, for a fleeting moment, slightly disturb sensitive instruments measuring gravitational waves, atmospheric pressure, and even minute tectonic shifts. Satellites might detect sudden changes in upper atmosphere turbulence. For those in orbit, looking down, Earth might appear to shiver ever so slightly, as though it has an involuntary itch across its entire surface. Culturally, the event would leave an unforgettable mark. News channels would run live sneeze countdowns, memes would flood social media in real time, and historians would mark the day as the moment humanity collectively sneezed. Comedians would have a field day. Artists would capture abstract representations of the Great Sneeze, and conspiracy theorists would claim alien interference or secret government experiments. Scientists might publish papers with titles like Global Sneeze Dynamics and Planetary Microvibrations, and children would grow up hearing bedtime stories about the time the world sneezed together. Finally, in the aftermath, the world would gradually settle back to normal. Slightly disheveled humans would survey minor damages, laugh at the absurdity, and perhaps reflect on the unity of the moment. For a few fleeting seconds, despite political, cultural, and geographical divisions, the entire planet shared one synchronized action: a sneeze. In that tiny, gusty instant, humans experienced collective chaos, comedy, and connection, reminding us that even our smallest, most mundane actions can have spectacularly global consequences. In conclusion, the synchronized sneeze would not destroy the planet, but it would leave an indelible mark on science, society, and collective memory. From minor seismic waves to the temporary atmospheric disturbances, from viral aerosols to worldwide laughter and memes, the day everyone sneezed at once would be remembered as the most bizarre, chaotic, and oddly unifying event in human history. Who knew that a simple sneeze, repeated 8 billion times in perfect harmony, could remind us of the delicate, interconnected, and hilariously unpredictable nature of life on Earth?